Hey everybody, it's Mr. N here again, and this is our second video on the substitution rule. These problems are just a little bit more difficult than the first video, so let's get started and let's get these done. So, on the first one we have the integral of 2x cosine x squared dx. So let's take a look at this, and since we're going to use U substitution, we are going to go ahead and let u equal the x squared. Now, here we might want to initially think that we would let u equal the cosine x squared, but what happens is if you do that, this becomes the u right here, and then the du becomes a sine, and not much can happen if I do that. If you go ahead and try that route, you won't be able to really reduce anything out to integrate correctly. So if this was your initial guess, you end up not really getting anywhere with it, so you have to guess something else. So this time we'll try guessing this. So since we let u equal x squared, du equals 2x dx. So du over 2x is my dx, and let's make our substitutions now. So we've got the integral 2x, and my u was this x squared, and then the dx is du over 2x. So as you can see now, these will reduce, and you just have simply the integral of cosine u du, which comes out to be sine u plus c, and let's make our resubstitution, so sine x squared plus c. Again, even I would think at first, oh, let's go ahead and try to use that as our u, but it won't work out. You'll just end up getting pretty much nowhere, so you have to start over. And that's common with substitution rule. If you attempt something and it doesn't get you anywhere, well, make a different u guess. All right, so over here for the second one, same thing. We're going to let u equal the x squared. Again, if you did it as ex squared, you will see that you don't really get too much out of it. So du equals 2x dx. So du over the 2x is my dx. So let's substitute these. So I end up with the integral of x e to the u, and then the dx, this substitutes into du over 2x, and now these x's will reduce. So you end up with the integral of e to the u du, and then you still have this over 2, so I'm going to put 1/2 out in front. So now this just ends up integrating into 1/2 u plus c. So we have 1/2 e to the x squared plus c. All right, moving right along, let's do the third problem. And on this one again, kind of difficult to see what should we make our initial guess. Well, as before, I told you go for the one that's the most complex. This is to the 4th power, right? So this is cosine 3x to the 4th power, if I rewrite it like that. So that's what I'm going to make my u. You could have certainly tried with a sine, and again, you'll notice that as you take the derivative, nothing really happens, and you'll still end up with cosines in that. So you'll end up with sines and cosines, too difficult to integrate. So du equals negative sine 3x times 3, don't forget the chain rule, dx. So my du over negative, let's put the 3 out in front here, sine 3x is what dx is. Let's go ahead and make our substitutions. So this becomes the integral sine 3x. Now this is cosine 3x, so this is going to be u to the 4th. So remember, I just wrote it like that. And then the dx became du over negative 3 sine 3x. So that reduces out. So we end up with, let's go ahead and put the negative 1/3 on the outside, integral of u to the 4th du. So this becomes negative 1/3, and then this is 1/5 u to the 5th plus c. So you end up with negative 1/15, and let's go ahead and make that resubstitution, cosine 3x to the 5th plus c. All right, moving on to number 4. here on number 4, let's take a look at this. We've got the integral of x squared times the square root of x minus 1 dx. All right, so let's let u equal this x minus 1. Again, what's in the square root there's typically a good first choice. So let u equal the x minus 1. Du equals dx. Let's make our substitution. So the integral of x squared root u, and this becomes du. Uh-oh, I've got an x and a u, nothing reduced out. Is there anything I could do here? Well, yes, I can. I can manipulate this and say that u plus 1 is the x. All I did was solve this for x. Because now I could put this x in terms of u, which is u plus 1 squared root u du. And I could go through and let's go ahead and FOIL this out and distribute. So this ends up being u squared plus 2u plus 1 times root u du. And I'm going to go ahead and move this up here. So now let's continue on. And this ends up being, remember, this is u to the 1/2, right? Root u is u to the 1/2. So let's go ahead and distribute that. So you end up with 2.5, so we'll write it as 5/2, plus distribute it again. We'll end up with 2u to the 3/2 plus u to the 1/2 du. So that's what we're going to integrate. And when we integrate this, we'll end up with 2/7, because we're going to add 1, so we get 7/2. So I need to get rid of that 7/2 to the 7/2, plus this will be 2 times 2/3, so 4/5. So yeah, so I should have said 5/2 here, because we're adding 1 to this, so it's 5/2. So this becomes 4/5 u to the 5/2. Again, we're adding 1 here to this, so this becomes 3/2. So I need a 2/3 u to the 3/2 plus c. All right, make our resubstitution. So this becomes 2/7 times x minus 1 to the 7/2 plus 4/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c. All right. Again, on all these, remember, if you take the derivative of your answer, you'll get the original problem after you simplify. That's how you know if you did it correctly. All right. For the next one, let's go ahead and I'm going to choose u to be that one because it looks like it's the most complex. It's up on the power. So we will let u equal the cosine of x. Again, picking u is probably, it's a critical step, and it's probably one of the most difficult ones to understand which one to do. But if you pick it wrong, you just start over and choose another one and see where it ends up. So you won't always get it right on the first try. Over here, du equals sine x dx. So du over the sine x is what the dx is. So we've got the integral of sine x e to the u, and then this dx became du over sine x. And those will reduce. So we've got the integral of e to the u du, which becomes, actually, this cosine is negative sine. I just realized that. Negative. So I need a negative out here. So this becomes e to the u plus c. And I will make my resubstitution, so cosine x plus c. And again, if you check this by taking the derivative would be negative e to the cosine x times negative sine x, so you will end up with sine x e to the cosine x dx. So this checks out. All right, for number 6, let's take a look here. Let's let u, let's change the pen color real fast. and we will let u equal dx plus 3. So that means du equals dx. And let's make our substitutions. So we've got the integral of x times u to the 8th, and this is just a du. Again, we have an issue. We've got x's and u's. So what can we do? We can take this, and we can say u minus 3 is your x. And make that substitution. So now we've got u minus 3, x to the 8th, u to the 8th, du. And now everything's in terms of u, and I can go ahead and distribute this, so I end up with the integral of u to the 9th minus 3u to the 8th du. And I'll go ahead and integrate this, and I'll get 1/10 u to the 10th minus, this will be end up being u to the 9th, so I need a 1/3 out in front of this, plus c. And let's go ahead and make our resubstitution. So x plus 3 to the 10th minus 1/3, and this will be x plus 3 to the 9th plus c. Okay, so we are on number 7 over here, and we are going to, for this one, let's move this up, and let's let u equal the x squared minus 1. This one, because it looks a little bit more difficult, and see where we end up with that. So du equals 2x dx, which would yield du over 2x for the dx. Now let's go ahead and make our substitution. So the integral from 0 to 2, x, and this becomes u to the 7th, and then du over 2x. Now these reduce out, and here we will end up with 1/2 the integral from 0 to 2 of u to the 7th du. At this point, I'm going to go ahead and show you two different ways to finish this problem. So we'll do option 1 over here, and on this one, we want to go ahead and integrate and then resubstitute. So we'll say integrate and resubstitute. So this ends up being 1/8 u to the 8th on the bounds from 0 to 2. So I can't plug in the bounds yet. I need to resubstitute first, and that's important to know. Resubstitute before you plug in the bounds, unless you do option 2, which I'll show you in a second. So at this point, we end up with 1/16, and this ends up as x squared minus 1 to the 8th on the bounds from 0 to 2. We plug this in, we get 1/16, 3 to the 8th minus 1/16, and this will be -1 to the 8th, and you'll get 6/561 over 16 minus 1/16, which ends up being 410. Okay, if we did this with option 2, and let's write this as option 2 over here. This time, you want to find out what these u values would be on the bounds. So we're going to say option 2 is changing the bounds. So we will change the bounds. So the way we change the bounds is we just plug in the original bounds from 0 to 2, so we'll plug in u of 2. When I plug in 2 and I put it into this u equation, I end up with 2 squared minus 1, which is 3. When I plug in u of 0, I get -1. So we can take it from this point where we had the 1/2 times the 1/8 u to the 8th, and now I can put in these two new bounds. So it'll be from -1 to 3, and now do not resubstitute. So that's a second option. This is actually a cleaner option when the problems get bigger. When this u value is kind of crazy, it'll yield lower numbers and just easier to do some calculations with. So this ends up being as 1/16, 3 to the 8th minus -1 to the 8th when I make my substitutions. So it'll be 1/16 times 65, 60, which gives me the same answer, 410. All right, moving on to number 8. So let's take a look at this one, and let's go ahead and start. We will let u equal the t minus 1, or I'm sorry, t plus 1. So du equals dt, and let's make our substitution here. So I end up with t over u du. Again, now I have a t and a u, and I want everything just in terms of u, so I could just manipulate this right up here and say u minus 1 is the t. So I end up from the integral from 1 to 3 of u minus 1 over u du. Well, this can break apart pretty easily, and we could say u over u minus 1 over u. So this becomes the integral from 1 to 3 of 1 minus 1 over u du. Again, I will show you this with 2 different options here. Let me fix the parentheses. And we will go at it in that manner. So let's slide this up a little bit. Okay, so option 1, we're going to do it like before, and we will not, we will resubstitute. So in this case, I'm going to take the integral, and I get, on this one, I'll get u minus ln absolute value of u on the bounds from 1 to 3, and now I have to resubstitute since I'm using this option. So I end up with t plus 1 minus ln t plus 1 on the bounds, this should be absolute value, sorry, on the bounds from 1 to 3. So this ends up being, when I plug this in, 4 minus ln 4 minus 2, this will be minus 2, plus the, actually it'll be minus, we'll just go like this, minus 2 minus the ln 2. So this cleans up into being 2 minus ln 4 minus ln 2, and we can take this a little bit further and say this is ln of 4 over 2, so the final answer is 2 minus ln 2. Okay, if we did this with option 2, let's change the pen color here, and we will do option 2 right here. In this case, I want to find what u of 3 is. U of 3, when I plug it back into the top, is going to be 3 plus 1, which is 4. Then I want to find u of 1. When I plug it back into the top, and I'm looking up here, that's where I'm plugging it back in. So again, you're taking, just to clarify, you're taking this one, plugging it in here, that's what u of 1 is going to be. And this ends up being 1 plus the 1, which is 2. So we could take it from this point, and we have u minus ln absolute value of u, change the bounds here, and then just plug that in. So you end up with 4 minus ln absolute value of 4 minus this 2 minus ln 2. And then you end up with 2 minus ln 2 when all is said and done. Same answer. All right, last problem. So let's move on to this one, and let's take a look. For this one, we've got the integral from 0 to pi sine x over the root 1 plus cosine x dx. So we're going to let u, we will let u equal the 1 plus cosine x, because that's the one that looks a little bit more difficult in there. So let me slide this over just a teeny bit. And let's do that from there. So let's take the derivative, du equals, this will be negative sine x dx. And let's make our substitution. So the integral, I'm going to draw a line here so we know which problem's what. Okay, so the integral from 0 to pi, and this will be sine x over root u times du over, oops, forgot to finish this one, du over negative sine x is what dx is, negative sine x. These will reduce, and so you're just left with negative from 0 to pi of 1 over root u du. Now, I'm going to just go ahead and do this problem without resubstituting, so I will just do option 2 on this one. it's less work. That's why I chose to do it that way. So when I integrate this, this ends up equaling 2u to the 1/2 on the bounds from 0 to pi. Now remember, I need to change these bounds. So u of pi becomes, this is going to be 1 plus the cosine of pi, and that's just 0. U of 0 is going to be 1 plus the cosine of 0, which is 2. So I will get negative 2 u to the 1/2 on the bounds. Now look at how this changed. This is from 0, this ends up being from 2 to 0, so we're actually going backwards. But your answer will work out that way. So when you put in, when you put in the 2, you're going to get negative 2, and this will be root 2. Actually, sorry, I need to do it the other way. Let's do it the other way. Put in the 0, you'll get 0 minus, now negative 2 root 2. So this, I put the 0 in first, then do that, and then subtract that. So this ends up being 2 root 2 as my answer. Now you could have done it with option 1, but again, I chose to do it this way because it's a little less work from the resubstituting step. So hopefully this video has helped. Good luck on your U substitutions, and make sure you subscribe.